V of t is 1.
Oh yeah, I forgot to do acceleration, right? Here I have one packet. Okay, so period. Make a little shout out to period 4. Period 4. Open up page 7 of your applications of differentiation packet and do it right now, and we're going to go over it in like 1 minute.
Hi, period 4.
Robert Rose says hi. You are supposed to make the position function, factor it, take the derivative, factor the derivative, take the second derivative acceleration, which is just 2, and then make beautiful sign charts for position, velocity, and acceleration. Okay, can we go over this? Are you guys done, basically? Okay, good. Helen says yes. All right, find the position of the particle at time 5. So that's just asking for S of 5. S of 5 is 12?
12.
Done.
Meters.
Part B. Part B says find the average velocity of the particle from t equals 0 to t equals 5. Well, average velocity means what it means. What does it mean?
Rise over run.
Okay, it is the change in position. It is the change in position over the change in time. In other words, S of 5 minus S of 0 over 5 minus 0. And that is therefore 12 minus 2 over 5, which ends up being 2 meters per second. Are we good? Say yes.
Yes.
Good. Find the instantaneous velocity of the particle when t equals 4. Well, that's just saying what is v of 4. So that's just 5, right?
Yeah.
Good. Part D. When does the particle change direction? When does it change direction? Answer. Why am I on the wrong problem? Oh, man. Thanks. I was totally... Wait, what's going on? Oh, everything was right until part D. Part D, find the acceleration of the particle when t equals 4.
2.
So, yeah, that's 2. Thank you. So that's meters per second squared. Part E, at what values of t does the particle change directions? Yeah, it changes direction at t equals 3/2 because over here it's moving left and then it changes and then it starts moving right. Good? Where is S a minimum? Where is the particle when S is a minimum? Yanni, at what time do we get the minimum value of S? At 2? Yeah, it is at 2. Yeah. So yeah, the minimum value. Wait, hold on. Where's the particle when S is a minimum? S will be minimum. No, at 2, S is 0. S is minimum when you've moved the farthest to the left. So that's going to be V is the derivative of position. So if 3/2 is a critical point, that means that that S is minimum. S is minimum at t equals 3/2. Right? Because the derivative of S goes from the derivative is negative, then the derivative is positive. But that's not what the question asked. It asked where is the particle when S is a minimum. So you have to plug 3/2 into S. What is S of 3/2? Did someone do it? Negative 1/4. That sounds right. Okay, good. G. When is the particle moving towards the origin? Moving towards the origin when S and V have opposite signs. So you're moving towards the origin on -infinity to 1, and also from 3/2 to 2. And when are you moving away from the origin? What? Moving away from the origin when S and V have the same sign. So that's negative, no. 1 to 3 halves, and 2 to infinity. You guys feel good about this? Good, next page. So, step 1, take the derivative, factor velocity, take acceleration, factor acceleration, make a sign chart comparing position and, well, make a sign chart comparing velocity and acceleration. I guess that's all you can do.
Ghost. What is it actually called? Oh, it was weird.
So that's the one you do, right?
Synthetic, yeah. I don't know why they call it.
Okay, never mind where position is 0, but what is very, very important is that you make them overlapping, okay, make them like line up. That way you can look and you can actually compare. You guys know what I mean when I say like nice overlapping? Yeah, good. So always do that first and then just go and like do the problem. Okay, I'm gonna give you like 2 minutes and then we're just gonna go over this page.
Oh, just because I was
Okay, can we go over this? You guys are too slow. Finish. Oh, you like moved on to the next one already? No, don't have to. Do it all. Alright, part A, I got 15. Is that what you got?
Yeah.
When T was 4, that's whatever it is. 48 plus 28 plus
Average velocity is same thing. Change in position over change in time.
Wait, what? 4? 4.
There's 9. So yes.
Yeah.
Where does the particle change direction?
At T equals 1 and T
At 1 and 3, yeah, it's moving to the right, then it's moving to the left, then it's moving to the right. So it changes direction at t equals 1 and t equals 3. When is the particle moving left?
from 1 to 3.
It's moving left on the interval 1, 3. When is it moving right?
Negative 3 to 1.
Negative 3 to 1 and 3 to infinity. Okay, now comes the only really challenging question on the entire paper. When is the particle speeding up?
3 to infinity.
When is it? No! T, no! No, 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 no. Positive acceleration does not mean speeding up. I have to give an entire lesson for which that was the only important thing. When is the particle speeding up?
3 to infinity.
Yes. When you're either moving to the right and the number expressing your velocity is getting bigger, which is happening on the interval from 3 to infinity, or you're moving to the left, as in you have a negative velocity and that number is getting smaller, which means the magnitude is getting bigger. So that happens on the interval 1, 2. Everybody with me?
Yeah.
T, with me? Good. How about part H, T? When is it slowing down?
Negative infinity to 1. And
Yes. And
2 to 3.
2 to 3. Everything else. Okay, good. You guys feel like you got this? Okay, good. Put it away. Bye, period 4.